Hey geometry class, this is our section on 4.8. This is our last section of the chapter too, so get ready for that test. What we're going to be doing in this section is learning a little bit more about these two types of triangles, isosceles and equilateral. And there's going to be some theorems, and we're going to apply those theorems in some examples that I show you. Okay, so let's get started. Alright, so if you recall, an isosceles triangle has at least two congruent sides, as shown here in this picture below. Here's two congruent sides, so this is an isosceles triangle. The two congruent sides are called the legs. So this side and this side that is being shown congruent, those are called the legs in an isosceles triangle. And then the vertex angle is the angle formed by the legs. So the angle that's being formed by these legs is this one numbered 3. So that is our vertex angle. And then the side opposite of the vertex angle is called the base. And what I mean by side opposite, so this is your vertex angle. The side opposite of that vertex angle is this one right here that the arrow is pointing to. So that right there is called the base of your triangle. And you see the two angles highlighted here, 1 and 2. Those things are called the base angles. So here we go. I'm going to write in what's supposed to go here. It says blank is the vertex angle. Well, we discovered that was angle 3. And then angle 1 and 2 are the base angles. So angle 1 and angle 2. Okay, so that's a little bit more that about isosceles triangles than you knew before. Here are a couple of theorems in this section. One is the isosceles triangle theorem. And here's how it goes. It says if two sides of a triangle are congruent, then the angles opposite the sides are congruent. Or down here I have below, this isosceles triangle theorem may be stated like this. The base angles of an isosceles triangle are congruent. Since we know what base angles are now, then by definition of an isosceles triangle, we should know that if the two sides are congruent, then the two base angles are congruent. So that's what that theorem states. The hypothesis is illustrated like this. We have an isosceles triangle, therefore these two angles right here, B and C, are congruent. Alright, now we can have the converse of that. If we know that two angles in a triangle are congruent, then we should have an isosceles triangle. So if two angles of a triangle are congruent, then the sides opposite of those angles are congruent, meaning this right here. We have an isosceles triangle here. If we know that angles are congruent, those sides there are congruent too. Alright, on these next 3 exercises that I have for you, we're going to find the indicated measurement as we're asked to find. And we're going to begin using those theorems that we just learned about. So using those theorems, we're going to find the measurement of angle F, which is right here. And if we know that this triangle is an isosceles triangle, which is being stated right here by these little tick marks right here, these two sides are congruent, therefore, using that theorem that we just learned, these angles are congruent. So I'm going to label this angle X, and this angle is also the same thing because these are congruent angles. So we have, now we can use that triangle sum theorem. We can say this angle plus this angle plus this angle equals 180. So we can say X plus 22 equals 180. And now we have 2x here, and I'm going to go ahead and subtract 22 from both sides. which equals 158. And then divide both sides by 2, we get x is equal to 79, which means also the measurement of angle F is equal to 79 degrees. And that's how we go and find missing angles inside our isosceles triangle. Let's do another example. Okay, it says find the measure of these two indicated angles. Well, if we know that this is an isosceles triangle, which we should know that by these little tick marks, then these two angles right here are congruent to each other. So we have that G is equal to x plus 44 and J is equal to 3x. Well, we should know that the measurement of angle G is equal to the measurement of angle J, because we know that angle G is congruent to angle J. Alright, so let's replace the measurement of angle G with x plus 44 and the measurement of angle J with 3x. Now solve your equation to figure out what x is equal to. Then we're going to plug it back in to find what G is. So subtract x from both sides, we get 2x. And then divide both sides by 2, we get x is equal to 22. So if we plug that back in here to find our measurement of G, we would get 22 plus 44, which equals 66 degrees. Now the other angle measurement we're asked to find is this angle measurement over here, angle H. Well, if we know that G is 66 and J is also going to be 66, then the angle left over from this isosceles triangle is just 66 plus 66, and subtract that number from 180 and you've got angle H. So let's figure that out. Measurement of angle H is equal to 180 minus 66 and minus another 66. So this measurement of angle H is equal to 48 degrees. And we're done finding those two angle measurements. Let's do one more exercise. Okay, so this last example, we're asked to find the measurement of angle N. So a lot like the last one, if we know this triangle is isosceles, then the base angles are congruent. So this angle is congruent to that one. So set these two things, the 6y and the 8y minus 16, equal to each other. So I'm going to set 6y equal to 8y minus 16. And then when I subtract 8 from both sides, or 8y from both sides, I get a negative 2y. Is equal to negative 16. Divide both sides by negative 2. When you take a negative 16 divided by negative 2, you get a positive 8. So there's y, but we're asked to find what is the measurement of angle N. So the measurement of angle N is 6 times 8, which is 48 degrees. And that is all the exercise I have for you on isosceles triangles. So let's take a look at what I have for you next, which is some theorems on equal angular and equilateral triangles. Okay, this next theorem, or corollary, as this thing states in this slideshow, is about an equilateral triangle. So it says if a triangle is equilateral, then it is equiangular. And I've told y'all this before when we were learning about different classifications of triangles. So simply put, that if we have an equilateral triangle, we know that by these little tick marks, then we should know that all angles are congruent too. So let's apply that in this exercise that I have for you. It says find the value of x. Well, we have an equilateral triangle, so therefore it is equiangular. Now, to figure out what x is, well, all these angles are equal to each other or congruent to each other. So I can say 3 times our measurement of angle L is going to equal 180, because there's 3 angles in our triangle and they're all equal to this right here. So 3 times that is equal to 180. So 3 times the 2x plus 32 is equal to 180. We have our equation that we need. So distribute that 3. We get 6x plus 96 is equal to 180. Subtract 96 on both sides. We end up getting 84. And now divide both sides by 6 and we get 14. Now if we're asked to find the measurement of angle L, K, or M, which are all the same thing, we would just need to plug our solution from what we got for x back into x, and that would give us our angle measurement, which it should be 60, because an equiangular triangle always is equal. All angle measurements inside it are equal to 60 degrees. Okay. Alright, this next corollary is just the converse of the previous one, which states if a triangle is equiangular, then it is equilateral. So if you see your picture, your illustration of your triangle, and all 3 angles are being marked congruent to each other, then we should know automatically that all 3 sides are congruent too. So let's use that fact and figure out what is y in this next example. Now in this example right here, these are side measurements. So nothing's going to be set equal to 180 like in the previous exercise. Those were angle measurements. All angles in a triangle will add up to 180 degrees. But side measurements have nothing to do with degree measurements. They're 2 totally separate things. Okay? So let's do this. If we know that this is equiangular, then we also know it is equilateral. So this side right here, NO, is congruent to this side over here. We can say NO is congruent to PO. Okay, which simply put, we should know that NO is equal to PO. Alright, let's plug in what is NO equal to. Well, that's equal to 5y minus 6. PO is equal to the 4y plus 12. Alright, so let's subtract 4y from both sides. We get y minus 6 is equal to 12. Add that 6 to both sides. We get y is equal to 18. There we go. We found our solution we were looking for. Y is equal to 18. Here's our very last exercise we're going to do together in this video. And this one relies on the information that we just learned in the previous slide. It has asked us to find the value of JL. JL is this side right here. So we're going to figure out the measurement of that side. And this is how we're going to do it. Well, LJ and KL and KJ, they are all congruent because this is equal angular, therefore it's equilateral. Since these two sides are congruent, KL and LJ, we can say that 2t plus 1, that side is equal to the other side, 4t minus 8. Okay, so we have our equation to solve for t. Let's solve for t. I'm going to subtract 2 from both sides, or 2t, sorry, and get 2t minus 8 on this side. And then add 8 to both sides, we get 9 equals 2t. And now we can divide both sides by 2 to get 4.5, which equals t. Now, we're not asked to find t, remember, we're asked to find the measurement of JL. Well, JL is equal to 2t plus 1. And 2 and t is 4.5 plus 1 is equal to 10. So there we go. JL is equal to 10. And we're done. So that's all I have for you, and be ready to do a lot of exercises in class, not necessarily a lot, but some exercises that will be applying these theorems just like we did in these exercises. So I'll see you in class. Goodbye, everybody.